Welcome everybody to our first project showcase. We're going to be talking about SUNY Poly in Utica, New York. It was an incredibly dynamic project and we have some of the project team here to tell you about it. We're going to share stories about design, build, delivery and the benefits and bumps in that, zero net energy and if what we expect will be the new normal and the challenges in that, and the schedules that were extremely tight for this project. There are some facts that are important to remember. The campus itself is a highly technical campus. This was a brand new construction project with really stringent goals, and our DASNY interior design team was a valued service in this process as well. You'll also encounter some acronyms. I'm not going to read through all of these, but just to put the point on it, most of the acronyms are about achieving a very low energy use goal, either zero net energy or setting a target so zero net energy can be achieved. Some of those services like commissioning are valuable in that process. And if you have questions, please ask them after the show. I'm going to turn it over now to Kara to talk about design build.
Thank you, Jody. As discussed, SUNY Poly was designed and constructed using the design build delivery method. Design build is a method of project delivery in which one entity, the design build team, works under a single contract with the project owner to provide design and construction services. So there's one entity, one contract, and one unified flow of work from initial concept through completion. The design build team is procured through a best value procurement process. In a best value procurement, although cost is part of the evaluation process, technical requirements, design, management, past performance, and other non-cost price qualitative factors that maximize the likelihood of project success are also evaluated. As part of the procurement process for SUNY Poly, DASNY provided with the RFP a set of bridging documents that had been created through a collaborative effort by the owner, the client, the facility, and the bridging consultant. Bridging documents convey design and construction requirements to design build teams bidding the project. Requirements are conveyed through a summary of work, technical requirements, plans, project constraints, reference materials, and contractual requirements. Bridging consultant is an integral part of the team and should be contracted with as early on in the project as possible. For the SUNY Poly project, the bridging consultant was a DASNY pre-qualified term AE consultant. Having a pre-qualified consultant to provide these services allowed DASNY to integrate them into the project at the earliest possible time, which was crucial to this project. At this time, I'm going to turn it over to Chris Keto, and he's going to discuss Z&E.
Thanks, Kara. So I'm going to discuss the more influential zero net energy aspects of this project. Probably the most influential one was the decision to make it Z&E ready, but unfortunately it was in the middle of the DB team's procurement. And this was a response to Chancellor Johnson's sustainability initiative to reduce SUNY's carbon footprint. Imagine to pivot of this magnitude at that time made it a struggle to achieve it, but we did it. But it wasn't without bumps along the way. An important key takeaway of all this is really to allow enough front-end planning time to clearly define the scope and the goals. An integral aspect of Z&E is to determine the project's EUI. Initially, the Chancellor's requirements were really quite stringent, but over time they have been relaxed slightly and more right-sized. A factor of EUI is determining the plug load of its end users. Imagine how difficult that is to determine ahead of time without actually metering the actual use. So during this project, we used a simple determination and provided a load for each occupant. Recent projects, however, we're doing it a little bit of a different analysis. It's a little bit more complex and hopefully more accurate. And I would imagine this is going to evolve over time. And then lastly, I want to talk about the geothermal wells that we're using for heating and cooling. This system uses the earth to either be a heat source or a heat sink. And as you can imagine, it's a pretty energy efficient system. One thing we determined during the design is we needed to use VRF, variable refrigerant flow system, which heats and cools simultaneously just to meet the EUI target. We discovered, unfortunately, that our favorite option, a valence system, wasn't efficient enough for a Z&E project, which disappointed a bunch of our staff. Now I'm going to have Tim McGrath discuss the scheduling aspects.
Thanks, Chris, and good afternoon, everyone. So this was a challenging schedule from the outset. The campus came to us a bit later than typical with the request in relation to when they needed the building complete. And then add to that, we had to amend the RFP for the design build teams midway through the RFP process to include the net zero requirements. So we went into this with eyes wide open along with the campus regarding the schedule challenges. Once we awarded the design build contract, the first challenge became the DB's team's understanding of the campus's requirements in relation to the many aspects of the net zero design. This was new and unfamiliar territory for the campus and to some extent to the DB team as well. A lot of time was consumed working through things such as energy models, plug loads, and building system options as they related to meeting the energy usage goals. The second challenge that we faced had to do with COVID. No surprise there. COVID impacted supply chain issues related to certain items. That caused the need to resequence some items of work and defer others until the semester break. COVID also impacted worker productivity to a certain extent due to the resequencing of the work, the social distancing and PPE requirements, as well as the loss of some workers that when we had to replace those workers with new workers, they had to go through a learning curve to get up to speed on the project. So how did we deal with all this? I would summarize that in three main categories. One, we had extraordinary efforts by our project manager and field rep, Nick Eustis and Tony DeStico, as well as the codes group and the PDQA inspectors. Many long days, weekends, and holidays pushing this toward completion. Two, we held weekly executive level meetings to ensure focus and engagement from principals of the design build team. And lastly, in the midst of this aggressive schedule and the stress related to COVID, we maintained a concerted team-based approach amongst DASNY, SUNY Poly, and the DB team. So that's a very condensed overview of the schedule, the challenges, and our strategies to address those challenges. I'm going to flip it back to Jody now to wrap up.
Excellent. Thank you very much. So we heard some great stories. Design build is a viable approach if we have planning time and good, clear goals early. Zero net energy will be the way most projects move very soon going forward, and we have to cultivate our own staff expertise. Schedules are always going to be a challenge, and there are things we can't predict, so we need to support our staff in the efforts to maintain those schedules. We appreciate your time. We're really excited about this project, and I hope that you stick around and ask questions and also reach out to this team at other times to learn about this project and the other fantastic work of the construction division. Thanks to Tim, Kara, Chris for joining us and sharing this project with us, and I hope you all have a fantastic day. All right. That was really cool.
That was pretty good.
22 minutes?
It came out at 9 minutes and 10 seconds.
Wow.
Really?
Beautiful.
All right, we're done.